All right, so these are your calculating average atomic mass notes. So just a reminder before we begin, the mass number is equal to the protons plus the neutrons. Isotopes are atoms with different numbers of neutrons. So they have the same number of protons but different numbers of neutrons. Atomic masses occur with decimal points because they are an average of different isotopes. All right, so the atomic masses that we see on the periodic table are these averages of all the naturally occurring isotopes. So what units do we use for this? Atomic mass units. They're defined as 1/12 the mass of a carbon-12 atom. They are the way that atomic mass is measured in the periodic table, and we abbreviate them as AMU. In order to calculate the atomic mass, you need the number of stable isotopes, the mass of each isotope, and then the natural percent abundance of each isotope. All right, so here's an example of how we use a weighted average in the real world. So it's how we calculate your grade in this class. So if you remember back in your syllabus, there are these 4 different categories that go into your grade, and they're each weighted differently. So major grades are worth 30%, minor grades are worth 30%, daily grades are worth 30%, and bell ringers are worth 10%. So you'll notice all of these percents add up to 100%, and they make your grade. So let's say you make the following grades in each category: 80 for major grades, 100 for minor grades, 75 for daily grades, and 90 for bell ringers. So the way that we would calculate your grade, or the weighted average, would be the percent as a decimal times the grade that you got, or times that value, and you do that for each part, and then you add them all together, and that gives you your weighted average. So it's more than just an average, where if I said 80 plus 100 plus 75 plus 90 divided by 4, that average would not account for the fact that they are weighted differently. So in order to take care of that, we have to multiply it times the percents as a decimal. So remember that your percents always add up to 100%. So that means that all of my decimals need to add up to 1. So it's just a good way to check and make sure that you converted from percent to decimal correctly. So in order to find the atomic mass, we would do a weighted average, but it would be, the atomic mass of isotope 1 times the percent abundance of isotope 1, and remember this percent as a decimal, plus the atomic mass of isotope 2 times the percent abundance of isotope 2 as a decimal. And you would do that for however many parts there are. So there's always going to be at least 2 isotopes you're talking about, but there could be 4 isotopes that you're talking about. So it would go out and you would do the same thing, adding all of the pieces together. And remember that you always have to convert your percent to a decimal in order to do math with it. So here's your first example. Calculate the atomic mass of chlorine if the 2 common isotopes of chlorine have masses of 35.45 atomic mass units with a 75% abundance and 37.29 atomic mass units with a 25% abundance. So first, remember to convert the percent abundances to decimals. And then we have the atomic mass of the isotope times the percent abundance as a decimal. We get this, plus the atomic mass of the second isotope times its percent abundance as a decimal. And we get this, and when I add those 2 together, I get the atomic mass for chlorine. So we're going to do another example. So this one is where you're actually looking for something, either the percent abundance or the mass of one of the isotopes. So calculate the atomic mass of one of indium's isotopes. There are 2. If the atomic mass of indium is 114.8200 atomic mass units, And one isotope of indium has a mass of 114.9041 AMU and an abundance of 95.795%. All right, so the way that we would do this is I would say, okay, so the atomic mass for the whole thing we said was, let's look, 114.820. So 114.820 AMU. And then I'm going to look for the atomic mass of an isotope and its percent abundance for 1. Okay, and so that was 114.9041. So 114.9041. And the percent abundance was 95.795%. Okay, and so I'm going to be looking for the atomic mass of isotope 2. And the other information that I can gather is I can gather the percent abundance for isotope 2. Because remember that all of my percents have to add up to 100. So if I say, okay, 100 minus 95.795, and that's going to give me a percent, well, where's my calculator, of minus 95.795 equals 4.205%. So even though it looks like they left me 2 unknowns, I could deduce this one knowing that all of my percents add up to 100. All right, so I'm going to set up my problem. I'm going to do it red. All right, so if I have the atomic mass, so 114.820 equals the atomic mass of one isotope, so 114.9041 times its percent abundance as a decimal, so 0.95795 plus the atomic mass of the other one, that's what I'm looking for, times its percent abundance as a decimal, so 0.04205. Okay, so if I'm going to, I'll type this, work this out, I would multiply the atomic mass of the first isotope by its percent abundance, so the 95, I would get 110.072. I'm going to leave it there. And then I'm going to say plus 0.04205. And I'm going to just make that x to make it simple. Equals 114.820. So if I subtract this from both sides, that's a point, minus 110.072, I get, so 114.820 minus 110.072, I get 4.748 equals 0.04205x. So then I'm going to divide both sides by this number. Get x equals, so 4.748 divided by 0.04205. And I'm going to get 112.913 AMU. And that would be the atomic mass of isotope 2. All right. So that's how you would solve one where you're looking for one of the atomic masses. So after this, you have some practice problems to work on. And if you have any questions, come find me and I would be happy to answer them.